Hey, good morning. Good morning, all. Switch on your cameras, please, so we can get started as soon as you're all ready. Okay. All right. Well, more of you should switch on your cameras, okay? Because I mean, imagine if this was a face-to-face class. You can't just come into class and um, and stand behind the door or something. Okay. So I think it'll also promote a sense of actually being in class and focusing more if you have your cameras on. Otherwise, if you have your cameras off, you could potentially be doing anything. Not that you're going to be, but I think the temptation to not pay attention is slightly higher if you have your cameras off. So if you have a camera on, I think there's a greater chance that you'll actually listen to what's going on in class and participate. Okay. And also, I can just be frank. That's basically what determines participation points and all. Okay, at the end of the quarter, I'll basically just try and remember whose faces I can remember, and who has been contributing and coding, and whose faces I can remember. If you just say, well, that person was mostly just a gray rectangle on screen. So I think that, well, okay, there's only a 50 to 75% chance that they were actually present in class. So that's how much the participation points should also be scaled down. Does that make sense? Okay, that's what I will do at the end of the quarter. When many students do email me saying, hey, I attended every class, but my participation points, I don't think, well, first of all, you won't know how many participation points you got because it's part of the system. But if they say, well, I should have got an A, how did I not get an A? And most probably the reason was because your participation points took a hit because I don't remember your face, or that you even participated in class. Okay, so that is the reason. You should probably pass this message on to your classmates too, right? The ones who are not in class, and the ones who are absent in class, they're just going for a B+, okay? I don't think the people who are absent habitually in class, I don't think they can ever get more than a B+ in my class, okay? So their ceiling is B+, and well, they can get something between a C and a B+, probably, if they do well in everything. But if they're absent in class and all, they're basically no chance of getting an A in class, okay? But we can be kind up to the limit, right? Up to the A, we'll be generous and say, if they've done good stuff, you'll get points, but you won't definitely not get the last bit. Okay, so today's class, well, yeah, Thursday is midterm and all, okay? So you guys are probably worrying about the midterm. How about this, okay? Technically, in the past, in the distant past, I got away without starting to talk about objects until week 7, right? So week 7 is next week. And week 6, you may not believe this, but week 6, I usually used to have the Tuesday lecture free, meaning that, you come to class, but no class. Okay. And, I'm just going to be hanging around and you guys just talk, and it's basically a review. And if people have any questions, they'll ask, and about anything. Okay. Anything we've done from the beginning, from day 1 until now. If you have any questions, if you have any doubts, if you want to do something over again, I'm perfectly happy to do all that. Okay, today's class, I can answer any questions you have about data representation, two's complement, bits and bytes, electrons, and all the way up to loops. What else did we do? Loops. Oh yeah, arrays. Okay, loops and arrays. So you need anything up to there. If you feel that you're even slightly, you know what? Thursday is my exam, and I'm still not 100% on this. I'm 99, but I'm not 100%. Okay, I know that feeling. That's right, because many times before exams, especially in math, right? Other subjects I didn't bother so much because many other subjects like history and all. It's just a question of remembering shit, right? Okay, so all right, do I remember it or not? I can look it up. But math and subjects like that, before the exam, I always used to, when I was a kid, okay, I always used to feel at the last minute, okay, I'm pretty sure I understand all that, but can I do it if I get the same question in the exam? Okay, because I know that never works for me, because and it's the same with computer programming, because I think that after having read through it and maybe even worked out little snippets of the code and say, oh, okay, that's how it works, I know everything. Okay, and then I actually get to program that really, right? In real life, I get to program that with a colleague, with someone else who knows the material. And I find that I'm stuck. I don't know what to do. And I have to go and hit the reference material. And I sometimes even have to try and understand, because sometimes you skip a small step and say, well, that happens, and go on. Okay. But that small step actually requires a bit of understanding. And that's probably the reason why I skipped it in the first place, because I skipped over the understanding part, which is hard. So just before the exam, I discovered that, well, you know what, that proof, I thought I knew it, but I actually didn't know it, because there's a small step that I didn't understand. Let me go and figure out that small step. And then I discovered there's a whole big field behind that small step. In order to understand that small step, I have to understand a whole lot. And I only have 2 choices just before the exam. Either I basically not understand it and just take that blind step and do it blindly, meaning, well, I'm going to do that because it works. I don't know how it works. Okay, but I'm going to do it. That's one option, and well, not a very good option if you ask me. The other option is to say, well, you know what, I'm going to try and understand that fully, and it's going to take me a couple of days. And so that's why, if you have any questions about any of these concepts that you don't understand yet, we can talk about those. Okay, if you don't have any questions, and if you want to work on another small project, you can come up with a good idea, right, and do something. Well, what was I planning to do last class? Well, last class, what did we do? Oh yeah, last class we did that star moving. Last class was a star moving, right? Star moving across the screen. Is that what we did last class?
Yeah, so we did.
Oh, okay, all right, okay. So I think what I was thinking then was that we'll do the star now, and next class we're going to start talking about objects, and then we'll try and create an object using that. However, because today's review and all, unless you guys want to keep proceeding, okay? And I think that's not the case. I think you guys don't want to keep on proceeding, because this week, you should basically look at it as, catch up week until and midterm week. We don't have to do objects until you want to, unless you want to. We'll definitely do objects, starting Tuesday. And today, if you do want to do a project, we can do a project, a small project, okay, small project, maybe even involving 4 or 5, 2 or 3. Right? Let's not be too ambitious. 2 or 3 students, working through some small program, like 20 to 30 line program, which uses all of the concepts that we've used, arrays, looping, branching, all of those. We can do that. That'll also try and cement the knowledge that we've picked up in the last couple of weeks, more firm. Make it more firm in your mind. That we can do. Or you can just ask about concepts and we can talk about concepts too. That's also fine. So it's entirely your call. This lecture, again, totally belongs to you, okay? Totally belongs to you. Hey, Kenneth, you know what? I think your screen brightness is very low. If you max out your screen brightness, then we can see your face also. Because I think what I noticed was, see, if I reduce my screen brightness, even I go practically like that. Oh, wow, that's 0. I can't even see anyone, right? Okay, it's not very, I don't know, I can't see. Can you see my, reasonable brightness? No, right? Okay, yeah. So yeah, if you increase the brightness, you can also see. It's basically the reflected light from the screen functions as a screen. Okay, so as a light, so you can increase the brightness, and then we'll be able to see your face too. Okay. All right. So what do you guys want to do? Hey, Adam, you got a question?
I actually do have a question about arrays.
Yeah, sure.
What if the size of function on an array? Does that give what does that give you?
All right. Okay. Very good question. Okay. That is a fantastic question. And something that you would have gotten bitten by well, maybe you will still get bitten by it. Okay. So what is an array? An array by name. Okay. So let's say you create an array of my array, 10 integers. Okay. And then you refer to my array square bracket null inside in your code. Now, what is that variable, my array? What is that variable known as to the compiler? And the runtime system, when it looks at my array, what does it see? Does it see those 10 integers?
It sees a pointer to the
first
location.
Yeah. Okay, great. And a pointer is nothing but an address. It is like, it's like 2564 Bayshore Road or something like that. Okay, it's just an address. And so if you have an address and you ask the compiler, by the way, the size of is not a language construct. Okay, well, it's a language construct, but it is not compiled. Technically it is compiled, but it is something that is done by the compiler itself. Well, even the code is replaced by the compiler. Okay, all right, let me take all that back. Okay, size of is basically a compiler directive, meaning that it is interpreted just by the compiler because the compiler knows what the size of the array is and things like that. A vector and puts it in, but because it's an address, it can't do a size of on an array. It'll just say, if you want a size of an array, no matter how big the array is, I'm just going to give you the size of a pointer. And a pointer is just 4 bytes or 8 bytes or whatever it is your architecture is, right? So it's only going to give you 4. So how do you find the number of elements inside of an array, right? So that's a very interesting challenge. Now, we won't go into that right now. It's not like super duper hard. It's just one line and you'll easily pick it up. You can just look it up too. All you have to do is find the size of the entire, actually, you know what? Wow, I even have to look it up now because it gives you the size of the entire array in bytes, and you divide it by the size of per element, and you get the number of elements. But if it's a pointer, how does it give you the size of the entire array? Well, okay, all right, this is what happens. Okay, so within the function in which the array is called, right? This is kind of out of the ordinary, so you got to remember this. Okay, if you have an array, this is your function. Okay, this is your function. Starts here, ends here, and you declare an array here. Within the array, within the function in which the array calls, I'm just talking off my memory. Okay, I might be wrong. You might need to look it up. Okay, so within the function, if you refer to the array, it'll return a size that is equal to the total number of bytes taken up by the array, right? If it's a character array of 10 bytes, 10 characters, it'll give you 10 because 10 bytes. But if you have an integer array of 10 integers, it'll give you 10 times 4. That's 80. Right? 10 times 4 is 40. Okay, 40 and so on. So it'll give you that many bytes. So no, but our intent is not to find out how many bytes the array has. We want to find out how many elements the array has because we index by index, right? We get 1, 2, 3.
How do you find out? Can we then divide by the size of like what we're putting in the array?
Yes. So you take the size of the array in bytes and divide by the size of what you're putting in the array, you'll get how many elements there are in the array. Now, technically, it is very rare that you have to infer the size of an array in C++. There are situations, I've come across situations where you have to do that, but most of the time you can just avoid them 2 ways, okay? One is just using vectors, because vectors are exactly the same cost most of the time, right? Unless you want to squeeze everything down to the very last machine cycle, people don't use native arrays. So use vectors, and vectors gives you the size like that, right? No matter what. In other situations, when you actually have to use a native array, well, you try and do the size calculation within the place where you've declared the array. So within the same block, you can get the number of bytes and divide and get it like we do, right? Yet another way to do it is basically, this is where you declared the array. So you said, int I, and within square brackets you said, size of the array. So you know that you can use that directly. So there's multiple ways. The only time when you don't know the size of the array is when you pass the array as a pointer, a parameter to some function. And the function doesn't know, because the function is in a different block. That block, if you say size of the array, it'll just give you 4. So there you're screwed. I think that's what happens, okay? I'll have to look up, the literature to find out what actually happens. But one of you should probably look up and share on the Reddit saying this is what actually happens when you do a size off on an array. And this is how you actually get the size. But it's not recommended. Use vectors, or use the constant that you use inside the square brackets to define the array in the first place, or calculate the size within the declared, within the scope of declaration. So those are ways in which you can get around it. And also the other reason why I discourage calculating the size of the array like that is that, if the calculation is off, you get really, really nasty errors, right? This is one-off errors, corner case errors in arrays, really nasty, okay? So ordinary bugs, logic bugs also you can figure out, but these corner cases and out-of-bounds errors, they're hard to find, because they'll go and modify something in your code, which is not inside the array, but it's some other variable. And that variable changed without your knowledge, and your program behaves completely differently. And then it takes a lot of tracking, at least 15 to 20 minutes of tracking, where you have to enter the debugger, put watch points and look at variables and say, well, that is supposed to be 4. Why is it 5? Right? And all these crazy things, right? It takes up a lot of time. So for those reasons, I recommend that use vectors. Arrays, we teach native arrays just to get an idea of what a vector is inside under the covers, okay? And in certain rare situations where you actually have to use a native array. But even today, what we'll do is, in fact, what we'll do today is we'll actually experiment. If we get a chance, after having answered all your questions, if we get a chance, we'll do a really short experiment, like 2 or 3 line experiment, like we did before, a 5-minute experiment, in which we'll do exactly what Adam said. We'll declare an array, try to calculate the size, pass the array as a parameter, find the size there, doesn't work, and so on and so forth. We'll try all those conditions and it'll be clear, okay? And so that is a good question. And I don't know if I asked that in the midterm. No, it's not in the question bank. Okay, good. I was afraid that, maybe I stuck a question in the question bank saying, hey, what is the size of the array? What is the size of the array? How do you calculate the size of the array? No, I don't. Because it's not really connected to CS2A. In my exams, I think usually, right, what I try to do, and I've also inherited a lot of questions from Michael Losaf, right? So you may recognize Michael Losaf because he was a previous prof at Foothill, and he is responsible for all the modules that we put together. You are reading your CS2A modules, hopefully, right? Not just a textbook, modules, because Michael's done a fantastic job, I think. I don't know. I can't judge the quality of his work, but for me, it has been, for teaching, it has been absolutely fantastic, because he has actually identified exactly the topics that I want to teach. Right? I don't know. Maybe because that's the topics he also wanted to teach. I don't know. Right? He has pulled out, because you look at the textbook. What is it? You're using Savage or something like that. It's like 600 pages. that big a book. And if you're going to teach all of that, it's going to be a pain, and it's not feasible. So I think what he did was, over a long time, he just distilled out just the essential parts that are spaced just the right distance, so that students can jump from here to there. Okay, not fall in the water. You can jump, and cover the whole book. Not the whole book, all that's required for CS2A. So that's what I'm doing. And so in my exams, what I tend to do is focus more on the concepts. Okay, exams are based on the are concepts, and questioning is whether you understand the concepts enough to be able to apply them in real life. And obviously, even though you can get past some of the questions without understanding the concept, the exam will catch you there, right? So the exam says, well, you know what, you passed the quest, but did you actually understand that step? Like my gut would have got me saying, well, you proved that theorem, but you actually understand what you did there. Okay. I would say, no, I didn't. Right. So take some marks away for that. So so that is what the exams are supposed to do. And I don't think they're meant to trick you. And I try not to ask you questions about syntax. Okay. Many other professors, I think, I don't know, because I haven't done all these other classes. But I hear that some students are being tested in other classes for C++ syntax. Okay, syntax saying, well, you know what is syntactically wrong in that fragment? Okay, and a student has to say, well, you know, there's missing a brace or semicolon, or you know, the for loop is right. So no, I don't do that at all. In fact, if you see a question in the midterm or a final that says what is wrong with this program and it's a syntactic error or stylistic, right? So again, style issues, I totally don't catch at all, because every person has their own unique style. I don't want to enforce it, except for class coding, because I'm coding with you, right? So style, if you do get a question, actually Michael did used to enforce style guidelines, you know, when he taught the class. So maybe there's 1 or 2 questions in the question bank, but you know, when I read the question bank, I removed those, but one of them may have sneaked in. So if you do get a style related question in the midterm or final, just let me know, and I just reinstate the points. Basically, you got a 1 lucky point there. Okay, if you get a style related question saying, well, what is stylistically wrong with that program, you should just say, hey, I got a style question. That means you got a point. Okay, freebie point there. So you got to let me know, right? Also, syntax related questions, I try not to ask syntax related questions. They're all meant to be concept, because syntax and style, nobody's going to care. The compiler is not going to care. Your fellow programmers will care, obviously. But syntax, well, you know, you write wrong syntax, the compiler is going to tell you in like 10 seconds, and you'll fix it. Okay? So I don't bother checking for style. Right. So we will actually try an example later on today to demonstrate what Adam asked. That, you know, size of operator on these things. In fact, we'll apply the size of operator to lots and lots of variables: size of char, size of int, size of long, size of double, and then a size of pointer, and then a size of an array. Right? We'll do all of that in 10, 8 or 9 cout statements, and look at the results and say, hey, that's what's going on. Okay. Anything else? Do you guys have any other questions you want to ask? I know there's a bunch of you who still haven't had a chance to code. Okay, you'll all get a chance eventually. Even today, if we start coding, one of you can, who's not had a chance, can pick up the code and we can. Actually, yeah. Adam.
For this is Darshana. For the midterm, is there a specific section that you might focus on, or anything like that? Like
Yeah.
sections?
Okay, so since we've already done data representation, a quiz on data representation, I won't be focusing on data representation issues. Yeah, okay, in the midterm. However, you need to know data representation, because in the midterm, you may have questions that require you to know certain things about data representation. Meaning that, you know, you may get given a loop and say, and a question that says, when would the loop terminate? Or when is the loop going to, what's the last number it's going to print? And if you look at the question with data representation in your mind, you'll see that, well, you know what, with the right data representation, this loop will never terminate. So the answer to that is the loop will never terminate, not 10, 7, right? And how do you know that? You know that because from your knowledge of data representation, you know that, you know, what is being compared on this side is unsigned. What is being compared on that side is signed, okay? And you're checking for less than 0. An unsigned quantity can never be less than 0. Right? So when it goes to 0 and you decrement it, it's not going to get to -1. It's going to roll over and become the maximum number. Yeah. And that you'll only know if you know data representation, right? And so, you know, that loop will be an infinite loop. And you know, and ask Walter. Is Walter here? Yeah, you can ask Walter. 2B students typically get stuck with that loop at least once. Okay, at least once that problem. Hey, my loop is not terminating. It's because of size t versus int. Okay, and you go to the Reddit and you'll see tons and tons of posts saying, hey, my program is not terminating, and because, and someone will say it's because you use size t and not int. Okay, or in int or size t, something like that. Yeah. So does that answer your question, Darshana?
Yes, thank you.
Arrays, functions, looping, and branching. Okay, focus on those for the exam, for the midterm. Now is that more specific?
Yes, thank you.
Yeah. All right.
I have a follow-up question to that then. So obviously in the quest, that is like a big opportunity for us to produce our own code based off of kind of like the skeleton of the format you give us. For the exams then, would a good study technique be to look through past quests or the codes in the module and kind of explain or like pseudo teach it to ourselves, walk through, make sure we understand everything, as opposed to churning out code ourselves? Or should we try doing both? Because that's kind of based off what you said earlier, kind of the approach. I was like, okay, these next 2 days, then I'm just gonna, as opposed to just fabricating fake problems for myself and coding them out, I'm gonna go through code that's already written and make sure that I could explain or like teach it to someone, for example. If there was someone who didn't know it, go through and explain exactly every step and why it's happening.
It's a good question, Thomas, and yeah. So there's 2 ways. If you want to, before a concept exam like ours, if you want to go via the quest code writing route, what you suggested, I hadn't thought about that before, but that might actually work. Okay, I don't know if it'll work. It might work where you take quest code and explain it to someone, because I wasn't thinking explaining it, right? If you explain your quest code to someone, almost every quest leverages all the concepts you have learned up to that day. So in the process of explaining it to someone else, you would automatically cover those concepts. However, I don't know if that's an efficient way to learn. I don't know. I think a better way might be to go through the modules, right? Don't go to the textbook, right? Especially not 1 day or 2 days before the exam. Go to the modules, Michael's modules, because he's actually picked out because with the textbook, he's going to be shuffling pages a lot, right? So, and then Michael has a lot of source code in his modules, right? Now, unfortunately, and it's my fault, okay? My fault, when I imported his modules into this thing that I have on nonlinear media, I screwed up the formatting. You might see, right? So the code, but not so much.
It's all shifted. Yeah, it's all shifted. It's not hard. You can just copy and paste it into Xcode. Usually,
that's what I was going to say. Yeah, that's what I was going to say. Wait, 2B and 2C, not the same. For some reason, 2B and 2C, the formatting got preserved. 2A got screwed up, and I never fixed it. The last 2 years, I never fixed it. But because of what Thomas just said, I realized that, well, you know what, they just have to copy it and paste it into Xcode and they get the right format. Okay, and when you copy it and paste it into Xcode, you get another benefit. Okay, it's ready to run right there.
Oh yeah.
Okay, so
sometimes it's missing like the main function and stuff. Sometimes it's just isolated, but yeah, usually you can just add that in easily.
Yeah. And in fact, it's good because then you get more additional practice and writing functions that use some stuff, right? That is really cool. And so that's what I would recommend before the exam. Go through the modules, which is a distillation of topics in the text, and copy and paste the code. Any code that you don't understand, copy and paste and try and run it and experimentation. Okay, when you experiment and find out, that fact is basically nailed to your head. Okay, if you read about it, it'll probably it's just been sellotaped to your head. Okay, so some strong winds and it'll blow away. Experiment. That's it. You'll remember it forever.
Perfect. Yeah, that gives me actually a lot of structure for studying today and tomorrow. So thank you very much.
Thanks. Yeah. And in fact, I don't know. Yeah, maybe I should make this point, what Thomas said in the syllabus, but you should probably share it with other students or the Reddit or Discord or whatever other channel you have, saying, hey, that structure. Say that you came up with a nice structure for learning, and I also thought it was a good idea, worth trying, certainly. So share it with your classmates and modules, and then trying out the code. Experimentation is the key. That's why in our classes, we always code and do lots and lots of experiments, right? As opposed to, 4 years ago, when I used to code on the whiteboard, or code on my computer with a projection, and everybody looks at the screen, and they're probably looking at YouTube on their screen. So it's a. Any other questions? Any other? Feel free to ask any questions. If you want 5 or 10 minutes to just talk amongst yourself to clarify issues about the midterm. In fact, that's something you can do, right? You can talk to each other for about 5 minutes and say, hey, are you anybody clear on this? Anybody clear on this? If nobody's clear on that, call me, right? And I'll come and explain that. But the better way would be to explain to each other, because when you explain to someone else, both parties are learning, right? Even the one who already knows it may, in the process of explaining it, discover something that they, some small thing out there that they probably missed appreciating the last time. Okay, so you'll discover these things in the process of explaining it to other students. And obviously Walter is also here to help out if we get stuck. So I think that would be a good idea. Andrew, by the way, before we go into the next question, I hope you solved your precision issue with that quest. So the challenge with that quest, really, if you in the spec, if you see, is that the challenge is not to get an approximately correct answer. The challenge is to get the exact answer that I got, and you will get the exact answer I got only if you leverage your data representation knowledge. Okay, so this is a quest that actually uses data representation knowledge, because data representation gives you very firm, clear examples that if you do certain operations in out of order, the answer will be different. Yes, because floating point, everything is. So you got to figure out how I add in my reference code the various numbers, right? Arithmetic progression. What is the sequence in which I add? What is the sequence in which I multiply things, right? And there's only a few, right? 5 or 6 different sequences, 5 or 6 different permutations in which you can calculate. And one of those is what I do. And you don't have to do trial and error. You can actually cleverly deduce the exact order in which I'm calculating these things. Okay, and that is a challenge in that quest. Andrew, I hope you solve that problem. If not, you'll probably solve it in the next, today or tomorrow.
Problem got solved.
Hey, awesome, fantastic. Okay, cool.
Worked through it, got everything solved, everything's in the right order. Thank you so much to the people who were helping me do that.
Yeah, I saw the posts. People were saying, don't use POW and don't use a math library and all. And absolutely, that is the way to go. Yeah, thanks. Anything else? No? All right. Okay. Here's what we'll do. Right. So I did come up with a project that we can do today. I just forgot. He came up with it and I forgot. Okay. Anyway, you guys talk for about 5 minutes. Yeah. Okay. I remembered. Okay. So so what we'll do today, I think, is very simple. If we get to it, right? I don't know if we'll get to it. If we get to it, do you know what a histogram is? Histogram? Raise your hand if you know what a histogram is. Okay, there are a few people who know, right? Okay, how many of you know what is a tally mark? A tally mark. Raise your hand if you know what a tally mark is. Oh, wow. Okay. Well, you know what? When I was in 5th grade, well, maybe they don't teach it in school anymore, right? In 5th grade, I remember actually my teacher, what her name? Wow, I even had her name a few minutes ago, right? So my teacher was teaching us how to count things. Okay, different things. Right? How many sparrows? How many crows? How many different kinds of birds? Okay, and you see them and you all right. And how do you count them? How do you count them? So you have you've seen ornithologists, people who count these things. They go with a list written up there. And these days they probably use software, but they go with a list, and every time they see a particular species, they'll put a tally mark, which is just a line, a vertical line against, this is sparrow, vertical line. Oh, another sparrow, another vertical line, right? A crow, vertical line here. Okay, and so on. So at the end of the day, they'll basically count all the vertical lines and say, well, I saw 15 sparrows today, 20 crows, and so on. Okay, that is called tally mark counting, right? That is, each one of those vertical lines is called a tally. Now, however, you already know that, because that's what we did. If you said 500,000, you remember, I said, write out the 500,000 as 500 times 1,000. All right, we're in the same problem here. So if you go at the end of the day and say, how many sparrows you got? Oh, I got this many sparrows, and there's a whole bunch of vertical lines. You're gonna have a hell of a time counting those lines because you get, out of sync and all. So a clever way to get around the problem is what they discovered a long time ago, I guess, right? When you do tally marks, you do 4 tally marks, and the 5th tally mark is a diagonal one that crosses out the 4 tallies. So now you can count in blocks of 5, 10, 15, 20. Okay, that's a whole lot easier. Yes. Now, when you look at a completed chart saying, well, these are all the birds and these are all the sightings of the birds, the quantities, then you'll see the distribution, right? Because birds that were seen a lot of times will have a long line of a long list of tally marks, right? So you can look at this and say, well, you know what, sparrows, okay, crows, robins, and so on and so forth. So you can see that, you can see the shape by looking at the ends of the tally marks. Yes or no? Yeah, that's essentially what a histogram is. A histogram is, you have, if suppose I give you a whole bunch of numbers, right? A whole bunch of numbers, random numbers from 1 to 100,000. And I say, now I want to know how many numbers fall in each bin. How many numbers fall in each bin, right? So how many numbers in the range 0 to 1,000? How many numbers in the range 1,000 to 2,000, right? So I have like 100 bins like that. Each bin is 1,000. Now, every time I see a number, I look at it and say, well, is that number between 1,000 and 2,000? Then I put it in the first bin, right? If is it between 0 and 1,000, then I put it in the 0th bin, and so on. Okay, so each bin will count the number of numbers that fall in that range, and at the end you're going to print it out saying, well, in this range you got that many of the that many candidates. In this range you got that many candidates. Now you look at that, you can see a distribution of the numbers. Okay, and if the numbers are perfectly uniformly distributed, you should get an equal number of tally marks for every single range. Yes or no? Okay, so your pattern of tally marks will pretty much be like a rectangle. It'll be slightly jagged because it's random, but it'll pretty much be like a rectangle. However, if I did tally marks on something else, right? If I did tally marks on student grades, okay, and then I say, well, I want to find out all of my students, how many students got failed, how many students got a C+, a C, B minus, B plus, and so on and so forth. Okay, then I do a tally mark counting just like that. I say, this is how many got C, this is how many got an A plus, this is how many got a B plus, and so on. Then I can look at the shape of that curve and say, well, that is a distribution. Most of the students got a B plus, right? Very few students failed. Very few students got A plus. Do you recognize that? That is usually what happens, isn't it? And what you see there is a bell-shaped curve. Usually, it's a bell-shaped curve. It's called a normal or a Gaussian curve. Okay, Gaussian distribution, because Gauss was the one who popularized it in the 1700s here. Okay, so it'll be bell-shaped because the outliers, they're not very frequent. They're not represented that much. Okay, but around the mean, you get a lot of these candidates. So we can actually see that. So we can generate a whole bunch of numbers and in different kinds of distributions. Let's start with uniform and say, well, and we're going to do tally marks, basically histogram, and see how many of these we got. Okay, and in fact, strangely enough, I think, hey, Walter, you guys actually did a histogram for something else later on in 2C, right? In an experiment outside of 2C, you did a histogram of something.
It was for our research. Yeah, when we were trying to make sure that our data was correct, we did histograms to make sure the distribution was normal.
Oh, yeah. Okay. Yeah, we'll actually try that. We'll actually try that. Yeah. It's really cool. It's really cool. So Walter and Riley were playing around with that after 2C last quarter. So we can do that. We can do a 2A version of that, and I think it'll be fun, but optional. Okay, it's optional. First priority today is for you guys to just have a conversation and talk to each other and find out what you need help on, right? That other students can help you with. Okay, so if other students can help you, great. That's fantastic. Right? Otherwise, you can call me or Walter, and we'll help you out. So does that plan look doable? We probably don't need more than a half hour today to do that histogram program. One student and a half hour, we can get that done. It'll be really cool. It'll be nice. You'll visually see the shape of the distribution. Visually, it's very nice. I think it'll look nice on the screen. So we'll try and generate that program. Anything else before you guys start talking to each other? Okay. The only thing I don't like is silence. Just talk about anything. If you don't have anything CS2A related, it's okay. If you talk about how many candy bars you got yesterday, right? Or what you dressed up as, right? And so you can talk about anything. Halloween is fine. Anything that's interesting, like earthquake. Earthquake today is supposed to be the first rain of the season and all. Okay, so all of that is up for grabs, and you can talk about anything. Okay? And if you like, I can just turn the laptop on, so I'm not in your face. You can just have a free form conversation. Okay, free form conversation. And keep this in mind. Okay, 20 years from now, remember, make a note, right? Say, Alexa, set a reminder for 20 years from now.
What's the reminder for?
Wow. Okay. Actually, right. Alexa, stop. Okay. So yeah, I don't even know if I'll have Alexa.
2042. Should I remind you?
No. Don't remind me in 2042. All right. So, yeah, Alexa wants to remind me in 2042, and I
You
probably
have
remember what I
Alexa?
asked. Okay, but you said a
You have an
reminder.
Alexa?
First note, this time. And second note, this one.
Alexa, delete all notes.
You want me to delete all your stickies, right?
Yes.
Okay, I've deleted 2 stickies.
Okay, good. I was afraid I would say, I was afraid it would say, well, I deleted 5,000 stickies. Yeah, I had a lot of stickies that I didn't even know, right? So, all right, good. So you should set a reminder 20 years from now. Most of you, you'll all be big shots. Because you're interested, you're doing things, and I can look in your eyes, I can see the passion to learn, right? And find out new things and asking interesting questions and all, right? So you'll all be big shots. And then 20 years from now, you can come and look at this video, right? Or maybe, your fans will look at this video and say, hey, you know what? This guy who's the CEO of Pluto Corporation, right? Bought 4 more planets, but in 2022, look at him, right? He was, he or she was in this video trying to program a histogram, okay? So, and you look at it and say, wow, that was really cool. Look how far I've come. Right. So, and that'll all be so super duper cool. And it'll be so much more fulfilling to watch than any Netflix show, right? If Netflix is still around in 20 years, right? It'll be more fulfilling to watch than anything you can ever produce or anyone can produce. It's just looking at yourself 20 years ago and saying, well, that was a genius in the making, right? So you'll be able to see that and say, wow, that is cool. And you can show that to your grandkids and say, well, that's a good example, right? Follow my example, right? And just don't do all the wrong things I did. Don't party like me, but do all the right things I did, okay? So, and you'd be able to say that. So, all right. So, are you guys okay? You want to talk? And I'm here. Okay, I'm going to be here. I'll just be behind the camera, right? I'll be out there maybe. And you can call me. Walter's here. And like before. And try your best to switch on your cameras too. The people who've switched on cameras in the past, that's okay. You can have your cameras off. But the people who've never ever switched on cameras, you should switch on your cameras, at least once in a while, so that I remember that you guys are here during class. Okay. So is everything okay? You can call me if you want to do anything. And what time is it now? It's only 8:43, so we can even start coding at 9:15. Okay, half an hour later, 9:15, we can start coding and do histogram. Unless I have another idea, which is probably cooler, we'll do the histogram. And again, the histogram is a simple program, so some of you who are more experienced should not volunteer to code that today. Save yourself for later. So someone who is a little less experienced should code today, and because we'll be guiding you every single step of the way. And we'll generate that, and you'll feel really good about yourself after having done that program. Okay, don't talk. I mean, don't be silent. Just keep talking, and call me. Call me if you need any help. Okay. All right. I'll talk to you soon. I'm going to be here.
Well, yeah. So I'm gonna ask a question. What is the difference between the size t and int? So the professor said earlier that your what is it called? Your loop might not end because you either use size t or an int. Like, what is that about?
Size t is an unsigned long.
Sorry.
A size t is an unsigned long. That's all I know about its actual data type. I've had loops just not work before when you use a size T as one of them and then an int in a different part of the loop. I don't know why that specifically would make it that a loop went on forever, but that's what I know about a size T.
A size T is, I mean, I think this thing, I mean, it is an unsigned long. When you define an integer, you can give it a couple of like modifier keywords like unsigned, which means it's only positive numbers. Remember the whole two's complement thing? It just ignores that and it just gets the full 4 bytes. If you tell it like long, it's gonna say, okay, I'm gonna use like twice as many bytes for this number. So it can be a bigger number, a much bigger number. And the reason, so all you really need to think about is with size T is essentially that it's limited to be a positive number, and it's used for a lot of indexes in like arrays and stuff for that reason, because you can never have a negative. So that's, good. And it's used for like sizes and stuff, which is also good because you're never going to end up with negatives with those. So the reason that it messes up loops is you can't compare an integer to a size T without changing one of them to the other. So just, I would recommend that you make your for loops with size T's. I mean, generally, unless you're going negative with your I variable, you can just use a size T. Especially if you're doing something related to arrays. I hope that answers your question, but if it doesn't, I'm happy to, or maybe someone else can jump in.
Yeah, that was great, Adam.
Answer my question.
I'll add on to that.
Okay.
Just for Adam's sake, the thing you're talking about comparing size T and integers, when you compare a size T with an integer, usually what will happen is the integer is implicitly converted to a size T. So it becomes unsigned, but what you may lose then is the information of whether it was signed or unsigned. So there's sort of a habit of not comparing size T to ints for that reason, because you don't want to convert it without knowing.
But like, what do you mean about comparing? Like, can you give me an example?
Like, yes, for example, like, let's say you had a conditional in a function, right? You wanted to check, oh, if this value is greater than this value. Usually we don't like to do, okay, one size T and then a greater than operator and then an integer. It's, yeah, that's why. So if you're using integers, you kind of want to stick with integers. And if you're using size T, you kind of want to stick with size T, just for that reason.
So Adam said earlier that integer can be negative and size T cannot, but like, what kind of like example that like integer can be negative? Like, I don't know how to ask this question. What can make an integer negative so that, like, to avoid that, we'll use size T? Do you get what I mean?
Yeah, well, what Adam was trying to say was just that because it's unsigned, it's not going to be negative. So integer can be negative, and that's fine. And the benefit of size T not being able to be negative is you avoid a lot of problems when you're assigning, let's say, the size of an array, right? You never want to assign the size of an array to be a negative number. So if you're using a size T for something like that, or maybe going through a for loop where you know you're not going to want it to go below 0, then you can also use a size T for something like that. Just as sort of a safety measure as well.
I see. Can size T be 0?
Yes.
Yes.
It takes some sort of control away from the user in exchange for a certain assured sense of like, it kind of handles a sort of like a whole section of corner cases that you would have to like specifically think about otherwise.
It minimizes control in
In
for
exchange,
stability. Yeah, in
yeah,
exchange
in
for
exchange
stability.
for like having to think about it less, I guess.
I see. Yep, that's good.
I guess what you guys are saying is basically size T covers a lot of cases where you don't want to really think about because you're working on what you're actually like what the program's going to be doing, but you don't want to think about all those corner cases. That's kind of the idea behind size T.
But there is eventually going to be like operation with arrays and stuff that requires int, right? Or maybe even double.
Yeah, there definitely will be, but it's size T won't get in the way of that. What all Adam was saying was really like, for example, let's say you're doing a for loop where you're going through an array of integers, and you know you're going to be comparing that integer with the size T's. I mean, technically you can still do it, but it's one of those things where I think it's just a good habit to not be comparing ints to size T's. So yeah, so you kind of just, it kind of depends on the case and what the code you're writing for is. So you kind of have to look at it and say, okay, well, do I need an integer or can I just stick with a size T for this? And it kind of depends.
I think, Walter, maybe I'm a little out of my depth here, but I think, yeah, I've tried doing it. I've made that mistake in quotes in like Xcode and the code worked. But then when I tried them pasting that, or not pasting it, but shifting it into the quest didn't like that. So I think it also depends, like if you're using it for quest assignments, it's probably not going to fly. It's probably going to tell you that it couldn't run the code. And I noticed there that I had to change everything, even though in Xcode it originally worked fine. For the quest, it didn't.
Yeah, I think it's because it's thrown up as a warning, which the quest will take and say, okay, let's terminate this since there's a warning, whereas Xcode will just say, all right, let's just keep going.
All right, anyone else?
How about the due dates for the quest? It's just, I don't know. It's just I guess it's more of a question for the teacher.
Are they not due Monday?
Like how it's what?
I'm pretty sure they're due Monday morning. Like you have to have submitted it by then.
Yeah.
Yeah.
So the exam one at Thursday, is it like a midterm or is it like a normal exam?
Earlier in class.
It's in class, that's for sure. Oh, okay. But is it just a normal exam?
Oh no, I'm sorry. He referred to this exam as a midterm this class. So I mean, I'm assuming it's the midterm. But if you look, yeah, it is the midterm because if you look at the syllabus, it's like we're on week 6, so we're pretty much halfway through the quarter, and it says like review / midterm or something exam. Exact.
Oh, I see.
Yeah, Walter, you might be able to answer this, but we take the exam outside of class, right? It's like you have like a window. It's the whole day, except it's like an hour long when you're actually taking it.
I actually don't remember, but hold on, Professor?
Yeah. What's up?
We have a question about
Mhm.
the midterm.
Sure. What's up?
Oh yeah, I was
What's
just
your
curious.
question?
I saw that I think it's like a 24-hour period you have to take it, except it's 1 hour when you start it. It's not in class, right?
You can
On
take it
Thursday.
anywhere. Yeah, you
You
can
can
take
take
it
it.
anywhere
Okay.
you want. Yeah. I had one student in the distant past who took it on a phone. Okay. And they were on a bus or something, and they took it on a phone. And Canvas and phones don't play well together. And they got locked out in the middle of the exam, and we had to mix it. It was a big mess. So please don't take it on a phone. Yeah. And don't take it in the shower and all. Okay. So, so just
Who
calm
takes
down
it
and
like on the phone in the shower?
yeah, on the phone in the
Do
shower.
you do that?
Yeah.
Do you do that, teacher?
Two,
Are you
two
saying
negatives
that you
cancel
do
out.
it?
I don't know. Two
You're doing
negatives
it,
cancel
aren't
out.
you? That's where you grade our exams, right? Or whatever.
Yeah, I think some people do too. But it's relatively easy. Okay, nothing to panic. As far as a midterm goes, I think it's pretty straightforward.
Oh yeah, I was just gonna ask one more formatting thing. Is it multiple choice, just like the data representation? And there's
Not all
like
multiple
writing.
choice. No. So not all multiple choice, but they're all objective style. Yeah.
Okay.
Objective means, yeah. Everybody know the difference between multiple choice and objective style? Because lots of people think that objective means multiple choice. No, objective means that the question can be corrected without human subjective input, meaning that a machine can calculate the score. So different kinds of questions. Objective questions are multiple choice, multiple correct answers. Right, you got to check multiple boxes. Fill in the blanks. But in short, there's a whole bunch of different types. Any kind of question that can be answered without subjective biases by the instructor are objective. Anything else? Although you just did, I didn't see you before. Did you just join?
No, I joined like 30 minutes ago.
Oh, 30 minutes ago. Yeah, okay. Yeah, so how to prepare for the midterm? Aldo wants to know how to prepare for the midterm. And I think, who was it? Adam asked this question, or someone asked this question before. Oh, no, Thomas. Yeah. Reading the modules is the best bet. Read the modules and for the first 5 weeks, and also try out the code. Okay, try out the code in the modules. That is not clear. Try it out. Arrays is included. Hey, I got to look.
I think arrays is through week 4. Like you're going through week 4 up to 5 in the modules.
Good. So I think arrays used to be in week 8 before, and then and I moved it because students were getting confused.
It's a preview to week 8. Like if you click on it, it'll shift you to week 8 essentially.
Oh, it does. It does. I see. Okay.
Kind of. Yeah, it tells you like preview to week 8, and then it's like 8. Blah 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 blah.
Okay.
But it's the very first time you'll see it though. It's sectioned under week 4, so you don't have to skip all the way down.
Great. Awesome. Anything else? If you don't have any other questions, we could actually start coding something fun. Okay, we could start coding the histogram program and see what we can get out of it today. Unless you guys want to talk more. Anybody want to talk more? Amongst yourself? No? We can start coding? Okay, all right. So we won't do objects. Yeah, sure. Go ahead.
Professor, what is a numeric literals?
Yeah,
I saw it in one of the quests and I don't understand it.
Yeah, so a literal is a constant value. If it's not a literal, it's a variable. So x is not a literal because it can take many values. Yes.
Mm-hmm.
Whereas 4 is a literal because 4 can be 5, but x can be 5 or 6 or 7. So literal means literal. Literally it's literally 4, man. That's what you say, right? Literally means you can actually see 4. So in English, for example, I think in English people say it was literally raining cats and dogs. right? So it was literally raining cats and dogs is wrong. It's wrong grammatically not wrong, because technically it could rain cats and dogs, but it is not. It's an incorrect idiom in the sense that literally, the word literally is a wrong adjective there. Literally means what you see is exactly what happened. So if you say it literally rained cats and dogs, that is an incorrect idiom in English. Although many people use it, right? So descriptively, maybe it'll factor into the English language at some point, or maybe it's already there. But if you say it's literally raining cats and dogs, that is a wrong English sentence, because that means you're actually saying that literally cats and dogs are falling out of the sky. Literally, right? So when you say literally this number is 4, it means 4. So literal constant, literals, numeric literals are numbers. String literals are strings with double quotes. Yeah?
Okay. Yeah.
Anything else? Okay. How about
something?
Yeah, sure. Go ahead.
So when you guys say modules, do you I'm not sure where you mean, because when I just see more topics, I don't see any like reading modules.
Wow, Mark, you don't even you haven't found the modules yet. Okay, it's week 5. Okay, so now I think you'll have a great time, because you just discovered it now. If you go to the syllabus, somewhere in the syllabus, there's a link saying here are the links to Michael Loseff's modules 2A, 2B, and 2C. Do you see that?
Second page.
Is it on? I forget, but it's definitely in the syllabus.
People put links in the chat as well if you want to just jump to it.
Oh yeah, Alec just put it there, I think. Yeah.
Oh, thank you.
There you go. CS2A. No, Connor, don't click on the one that Connor pasted, because that one is for CS2C, right? The one that Alec posted is CS2A.
Yeah,
You good now?
Thank you. Mm-hmm.
Anything else? Okay. Otherwise, how about today? Either Leonardo or Philip or Ashley or Connor. Okay, those are the only 4 people who haven't had a chance to code, I think. Oh, Kenneth, you haven't had a chance to code, Ken. So one of you guys should feel free to take the screen. I don't know, Robert, I think maybe he had a chance, but maybe he was just vocal and I just misremembered him as coding. Robert, did you code?
I haven't.
You haven't coded. Okay, all right. So it's just because you're participative, I just think that you may have coded. So all right, good. So anyone who hasn't coded,
I haven't, but yeah.
No, you can wait. You can wait
Should
until
I?
later. Yeah. I think let's just wait until later. Because you've been participating in class. You've been participating in when other people are coding, right? So that basically counts pretty much as a coding experience. So you can, well, really, you'll get a chance, obviously, but let's reserve it for later. How about Ashley? Right? Where's Ashley? I saw her just a little while ago. Ashley, are you here?
Oh yeah, I am.
Do you want to code? Yeah. Do you have a Mac or a PC?
I have Mac.
Yeah. Don't worry. Don't be antsy or hesitant. Okay. It's going to be fun. I guarantee it'll be fun. Don't be. And I like all the posts that you're making. Right. Every time we cover a concept, you make a single post saying, hey, you know, the difference between plus plus and minus minus or something like that. Okay. I like those things. Very nice. Yeah, take the screen and then what we'll do. This
sorry, I need to open the.
Yeah, take your time. Take your time. Take your time. Oh, I forgot functions. Functions is also there for exam. Okay, I didn't mention functions. Functions, parameter passing by copy and reference. That's also super duper important. So we have functions, parameter passing, loops, branching, arrays. Okay, those are the important topics. Today, I think we can do all of it inside of main, maybe. We don't have, well, yeah, all right, we should ideally use a function so that you get practice in using functions. Okay, all right, so we'll write it as a main with one function, one or two functions. Yeah. Simple, I will keep everything very simple. And you don't have to go to VS Code or Xcode, Ashley. You can just share a browser. Yeah, excellent. Just like that is fine. Okay, so you can control Command A and delete the whole thing, and then we can start from scratch, right? So put a comment at the top saying class code for, what is it today? November 1st? Class code for November 1st. We are going to try and histogram a bunch of random numbers. I think that's reasonable. We're going to try, oh yeah, 22. We're going to try and histogram a bunch of random numbers.
Yeah.
Oh, it's auto-completing. Yeah, wow, inside of a comment, it's auto-completing W2 while. Try and no, and A and D.
Oh, and
histogram, HISTOGRAM. A bunch of random numbers. Okay, now you can put a blank line there and go and include hash, include IOStream. Hash include IOStream. Yeah, on the next line, one more blank line and say using namespace standard. Using 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 namespace standard STD space semicolon. Yeah, all right. Now so here's a choice for you guys, all of you guys. Do you want to use vectors or arrays today? You know, both will work. Vectors, if you've never used vectors, just like arrays, but you get a few niceties with it. Arrays, we can still do it. This is going to be a few, things that we need to do to fact, like, size off and things like that, Adam brought up. What do you want to do, right? Do you guys want to use a vector, which will be simpler, or use an array, which will force you to understand more concepts? I don't know. Either way is fine, because it doesn't matter. You'll pick up these concepts. What do you want to do? You guys all tell me, okay? Shall we use a vector? Should I actually use a vector or just a native array in this program?
I'd use a vector.
Yeah, okay. One more vote, and then we'll just go for a vector then. So how many votes for vector? How many votes for array? Vector? Okay, right, let's use vectors, okay? Because we haven't used vectors, and if people who want to learn about arrays can look at the previous class, because we used arrays in the previous class, okay? So go to the previous line at the end of line 4 and hit enter. And hash include vector also. Hash include. No, on the next line, So say hash include. No, hash include, not a comment. Just say hash include. Hash. No, the hash, the pound sign. No, the pound sign. Shift. Gone. Shift 3. Same as the previous line. Just copy. You can copy the previous line and paste it again. Copy the previous line, paste it again, and change.
Because I'm a international student, so I'm not really familiar with these symbols. So sorry.
Yeah. Of course. No. First of all, okay, no need to apologize for anything. Okay, no need to apologize, because I make goof ups all the time too, right in front of you, right? Many times I've written code and it didn't work, and then we got stuck with error. Nobody needs to apologize. Okay, we're all trying things out here. No, you're not doing anything wrong. So it's okay. Everybody's like that, and the only difference is you're on screen and coding. Okay, so you say, here's what you should do. Try hash is actually shift 3. What you just typed, that is what is called a hash character. Now, instead of typing the whole thing out, just copy line 4, triple click on line 4, 3 clicks. Yeah, copy and paste it one more time on the next line. Paste it on the next line. Yeah, paste it and hit enter. No, yeah, there's hit enter. Now change the second IO stream into vector. Double click on IO stream, double click, yeah. By the way, all of you, this is a recommendation for all of you, get into the habit of double clicking and triple clicking instead of clicking and dragging, okay? And it will save you a whole bunch of time when you're high-speed programming, okay? When you're professionals, double clicking and triple clicking gets like it, gets the whole thing just like that. Whereas if you click and drag, a lot of your cognitive facilities are tied up. People don't realize that, but a great deal of your mind is taken up when you click and drag, because your motor skills, your brain needs to focus on your motor skills, and okay, all right. No, you don't need to do all that. Just do hash include vector. How did you put all that in? How did you put it in, or
I just clicked the vector and it appears all the.
Wow. Yeah, get rid of that. Don't autocomplete there. I was just talking about autocomplete, but we just need the word vector, nothing else. Yeah. All right. Okay, good. Now let's go to line 9 and open your main method here. Say int main open close, int main open close. Yeah, space and then a brace. Put a space there. It's always nicer, I think. Yeah, and then hit enter a couple of times, and then put a return 0. Return 0, and that is what you start with every time. That's what you start with, and that is your basic code, but except for the vector, which you may not use every time. Okay, so the first thing we want to do is in main, put a comment right there where your cursor is. Start a comment. Well, we need a vector. Obviously, we need a vector. Okay, and then we need to know how many elements there are in the vector. So let's say we have a vector of 50, let's say we have a vector of 20 rows. Okay, well, let's say we have a vector of 20 rows. So no, we'll put the comment on the next line. Okay, so get rid of the comment, and inside on line 11, on line 11, right? Indent in. No, indent in. Yeah, all right. There's a indent in, and let's put the vector declaration there, and then we'll put the comment. Okay, just go back and get to column number 4. Yeah. Delete that. Move to column 4. Delete that. No, you delete the whole line. Yeah, delete the whole line, and then move to column 4. 4 spaces. Not there. Where the cursor was. Yeah, right there. On the first line. Not that. Line 11. Line 11.
Yeah.
4 spaces. Yeah, there you go. Four spaces. Okay, there you go. Say a vector. Vector, and within square brackets. No, not a comment. Just say vector. Within angle brackets. Okay, open less than sign there. No. After vector, open less than sign. After vector, not before. Okay? Less than sign. Right? And inside you're going to say size t, meaning, so you're telling the compiler, I want a vector whose contents are going to be size t, guys. Okay, I want a vector of unsigned integer. Size t is basically unsigned integer. So you're telling the compiler, give me a vector which is going to hold unsigned integers. That's what that means. Right? Now go to the right of that. Go to the right. No. Yeah, there you go. Space. And we're going to call our vector counts. 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 Yeah, count. Counts, because that is going to hold our counts of all the numbers. Okay, counts, and within parentheses here, within parentheses, you're going to say num underscore bins, all uppercase. Okay, num underscore bins. Okay, bins or num. Yeah, I will say num. Yeah, num. Yeah, open parentheses. Open parentheses. No, parentheses. Parentheses. No. Parentheses. Or shift. Shift 9. Shift 9. Yeah, there you go. There, you're going to say all uppercase now. Okay, all uppercase. Just type NUM. No. Don't type all uppercase. You type shift NUM num, right? Num, all uppercase, all capital letters. Num. Yeah, num underscore bins BINS. All uppercase, everything is uppercase, okay? Because we're going to make that a constant. BINS. Yeah? Okay. Very good, very good. Okay, put a semicolon at the end of the line, and then go to the previous line, and we'll define numbins there, okay? Previous line, on the previous line, say, yeah, enter. Now you say size t, num bins, size, no, const size t, okay? So start with const, CONST, const. No, CONST, yeah? Space, size t, and then space, num underscore bins, uppercase, right? Uppercase, yeah. Equals, space equals, let's say we're going to have, let's say we use 20, let's say we use 50 bins, okay? 50 bins, 50. Okay, which means that we're going to get numbers and we're going to put them in bins. Right? So 50 bins, that's 50,000 numbers from 0 to 50,000. We'll have 1,000 numbers in each bin. No, we'll do numbers from 0 to 100,000, which will give us 2,000 numbers in each bin. Okay, good. All right, good. All right, now go to line 12 and hit enter a couple of times. Okay, one more time, one more enter. Okay, now here's what we're going to do. Put a comment there. Yeah, let's say, yeah, put a comment. Say, now we generate a bunch of random numbers. And in fact, let's make it even more readable and better. We say a bunch of random numbers. A bunch is a very vague term, right? Nobody knows how much a bunch is, right? It could be 10, it could be 20. So let's go right to line 11, hit enter. We'll create one more constant, right? One more constant right there on the next line. Say const size t, space size t, num integers, right? All uppercase again, right? Anything that is const should all be uppercase. Num ints, INTS equals 100 times 1,000, okay? Which means 100,000 numbers. 100 times 1,000. No, times, it's a star, 1,000. Okay, all right, great. Now, now we're in our comment on line 15 where we say we generate a bunch of random numbers. You can say we generate num ints random numbers. Okay, not a bunch of. You can say num ints random numbers. Yeah, random numbers, and count how many fall in each of 50 equal ranges. And count. Next line. Now hit enter. Now you just go, yeah. Now open, you can't comment there. Now, how many of these numbers fall in each fall in each of 50 equal ranges? Actually, num bins equal ranges. You should say num bins equals ranges, right? In each of num bins equal ranges, 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 right? And change the 50 into num bins. Okay, num bins. 50 should be num bins. Okay, now, does that make sense so far? This is where basically we just put comments there. All right, now, so after that, on the next line, on line 17, we're going to start a for loop, okay? A for loop that is going to generate num ints random numbers, okay? So we'll say in our for loop, for size t I equals 0, I is less than num ints
Num ints.
yeah, that's one. Yeah, semicolon, space, and then I plus plus. Now you can make this statement, that line, a little more readable by putting some spaces around the operators. The I equals 0, put spaces on both sides of equals. Yeah, and then a space after the semicolon also. No, after, not before.
Okay.
There you go. All right. Now at the end of the line, open a brace, right? Space and then a brace, space and then a brace. Okay. Now, yeah, there you go. Okay, that's the body of our for loop. Now all we need to do is first generate the random number. So say int my rand equals int space my random equals my random number. So my rand, okay? My underscore rand. Yeah, very good, very good. And equals. No, space equals. Yeah. Now we're going to call the rand function, which will generate a big random number, but then take the remainder modulus 100,000, right? So that'll give us a number between 100, right? So you're going to say rand open parentheses, close parentheses. Open, close. Open parentheses, close parentheses. Yeah. Open parentheses, close parentheses. Yeah, space. Percent. That's a modulus operator, right? Percent. Num ints. Okay. And we don't need to do semicolon there. We don't need to put a comment here. Previously, we put a comment saying, well, that will generate a number in that range, but we won't put a comment here because hopefully it is self-explanatory. Yeah, is everybody clear what that line does with the modulus operator or not? Ashley, are you clear what that modulus operator does? I can explain if not, okay? All right, so you're peeking at the screen so I can explain. So rand, that function, when you call rand, is going to give you a big number. You know, it could be millions, big number. It's a random number, but it's a big number. But we don't want a big number. We want a number only between 0 and 100,000. Yes? So what we'll do is we'll take that big number, divide by 100,000, and take whatever is left over. That leftover part has got to be less than 100,000. Yes? Remainder should be less than 100,000. So that's what that does. The percent sign basically says, divide by this and give me the remainder. That's what the percent sign says. That is called the modulus operator. Yeah, is that clear? Okay, all right. So semicolon at the end of that line. Yeah, a semicolon and hit enter. Now here is a little bit of this is I think non-straightforward bit. Okay, so this is the only non-straightforward bit I think in this code that we may have to spend a few minutes understanding, but that's all. It's very simple. Okay, one more blank line, and then put a comment there saying determine the range, determine the bin into which this number would fall and increment that bin. Okay, no, determine, M-I-N-E, not determine. No, D-E-T-E-R, D-E-T-E-R, and then last four letters are M-I-N-E, M-I-N-E-E-E. Last, no, E. Determine, right? There. Determine the bin into which this number will fall and increment that bin. Into I-N-T-O, into which, yeah, very good. This number will fall Next line, and increment that bin. C-R-E-E-M-E-N-T. Yeah, this is where you need the M-A-N-T. And you were thinking about increment already when you were typing determine. That's why you put the M-A-N-T there, I think. Okay, increment it, I-T. Okay, it. Yeah, on the next line, they're going to say, oh, well, don't autocomplete. It's doing all crazy things, you know, when you do autocomplete. Especially hit Control K, hit Control K right there. It IT. All right, enter. Enter. Okay, now you say size T bin NUM, right? Size T bin num, right? Now it's a variable, not a constant, right? Space bin underscore num. Don't autocomplete. Bin underscore num. Underscore num equals. Here's how I'm going to calculate the bin number. Okay, and this may everybody I think has to think about this for a couple of seconds, and then it'll be clear. Okay, I'm going to take the number and then divide it by the number of bins I have. Does that give me the bin number? No, I'm going to divide it by I have to divide it by 50,000, right? How do I get the bin number from this number? Okay, I got this number. In order to find the bin number, I got to divide by how many do we have? We have 20. So that means I have to divide by 50,000. Oh no, how many? 2,000, right? Every number, yeah, 2,000, right? Okay, 100,000 numbers, and then we have that many bins. So we have to divide it by 2,000, and 2,000 is how do we get the 2,000 here? 1,000 divided by 50. Okay, so I think what we can do is number of bins is 50. Size to make it clear. Okay, let's one more statement just to make it clear for students who are going to read this code. You know, if you're in class, you can follow what's going on, you'll understand it. But there are students who are going to read this code. So go to the previous line. We'll just create one more variable. Okay, just so that for people who follow the code, it'll be easier later. Go to the previous line. We'll create one more variable. Previous line, hit enter. On line 21, hit enter. Yeah, hit enter. They say size T bin size equals size T bin size equals size equals num ints divided by num bins. Is that clear, everybody? Yeah. Okay, now later on, after having finished this for loop, we're going to do one thing. Okay, that statement there is what is called a loop invariant statement, meaning that it is going to be the same value repeatedly. Every time in the loop, it's going to calculate the same value because it's not calculating something based on I, right? It's going to be the same value. So technically, the compiler can move that statement outside the loop and get faster performance. So that's what the compiler is going to do anyway. So modern compilers will move it out, but we can also move it out just for aesthetics and make it very clear, right? So we'll do that later. Right? Num bin, the bin number equals my rand divided by the number of bins, right? Divided by bin size, divided by bin size. My random divided by bin size. Okay, and we will never get 100,000, right? So we won't get 50 at all. The maximum we'll get is 49, and our array size is 50. Good. All right. So that will, you know, there are corner cases here that you may get bitten by if you did it yourself the first time. So here's what I would recommend after we finish this today. Without looking at what Ashley coded today, each one of you is going to code this from scratch without looking at the code. And you know what after she's done it, we'll know what's going on. So you're going to have to reproduce the exact same thing without looking at this code. And the reason I say that is because there are some corner cases that you'll run into and have your program crash, right? I would like for every one of you to have a crashed program at least once, okay? Saying, oh, you know, I had a corner case and broken pointer, something happened. And I want all of you to experience that, which we actually kind of circumvented here by doing, you know, being more careful. But, you know, when you're starting out coding, you're not careful, and you should not be careful until you get bitten, and then say, well, that's why I need to be careful. Okay, good. All right. So on the next line, what do you have this closing brace? What is a closing brace for? The next one on line 25. All right. Okay. So here's what we're going to do. What we're going to do is say counts, square bracket, counts, square bracket, counts, square bracket. No, square bracket. Immediately after counts, you just say square bracket. I think it's shift. Oh yes, yeah. No, square bracket. You're confusing counts with couts, right? They both start with COU, but counts is our variable called counts. Right? Counts, square bracket. Square bracket. Yes. That thing there, that square bracket. I think it's shift curly brace. Yeah, curly brace. Yeah, that. Yeah. No, not that. That's a curly brace. Square bracket, like that.
I put it in a Mac. It should be the same key as the curly brace. Just don't press shift.
Okay.
Yeah. Right now here you're going to say bin underscore num. Underscore num. Yeah. And then at the end of that line, you're just going to say plus plus. At the end of the line, after the square bracket. No, not there. At the end. Which means you're going to that bin, getting the number from that bin, incrementing that number and putting it back. That's what's going on, right? All these things will take a few minutes of reading and understanding for beginners, and it is very important that all beginners go over every statement in their minds and try and understand what's going on. Okay, it's super duper important. And believe me, this will all set you up for totally enjoying CS2B and making a great, making something really cool out of this journey is understanding the early part of it. Later on, it's a different kind. It's not like this. Okay, so that's it, right? Semicolon right there. Put a semicolon there. Semicolon. Yeah, go ahead. If you have any questions, you just ask. Get rid and then get rid of the curly brace. Get rid of the curly brace. The next curly brace on the next line. Get rid of line 26. Yeah, I'll show you. Right, just triple click on that line. Three. No, not there. Triple click on that line. Triple click. Bam, like that. No. When you triple click, it's selecting the whole thing.
Yeah.
Wait, we need that curly brace though. Isn't that part of the for? Isn't that what's enclosing the for loop?
No, she has one on line 27.
Wait, I see.
Yeah, okay. You don't need that blank line either. You get rid of the blank line. All right. So now let's do one thing. Triple click on line 22. You can triple click on line 22. I think that will select the line, not the whole block. Triple click, 3 clicks. Tap. 3 clicks. Okay, now hit Command X. Okay, good. It's cut it and put in your clipboard. Now go up to just before line 17. Before line 17 and create a blank line there. Create a blank line. Yeah. Now paste it. Command V. Oh, it didn't indent it properly. Just got indented. Indented. Yeah. Okay, all right. So now go to the end of the for loop, right? And then hit it one more enter. No, and after the for loop. Okay. There you go. One more enter. Now put a comment there. One more enter. Now put a comment there saying now we print out the counts, right? Now we print out the counts. And then let's use let's print out the numbers first, okay? And then next step after that, we'll print out numbers and then followed by stars so we can see the shape. Okay. All right. So now on the next line, you're going to say for size t I equals 0. In fact, you can copy. No. Yeah, you can copy line. Yeah, copy line 18. Triple click on line 18. Triple click on line 18, and then copy that down there. Copy that. Now change. Indent it properly. And then change num ints to num bins, all lowercase now. No, was it num bins? What is it? How many? Where's our number bins? Num bins, yeah, uppercase, all uppercase. Num bins. Okay. Right. And on the next line, you're simply going to say indent in, right? Cout. And then we'll say, can you move your mouse a little bit? I want to see the loop there because it's overriding. Yeah, size I equals 0 plus a num bins. So 0 times bin size is that 0 times bin, so this side, and then 0 plus 1 times bin size is that, and minus 1. Okay, good. All right. So here's what we're going to do. Before you have the cout, let's actually calculate a few values to make it very clear to students. Okay, so right here you say int start of range, int bin start, yeah, bin start. Okay, bin underscore start equals I times bin size. Bin underscore size, yeah, semicolon. And then on the next line you can say bin under bin no, not star, by the way, it starts bin start, yeah, that's good. Right, on the next line you're going to say bin end int bin end equals I plus 1 within square bracket, within parentheses, I plus 1 within I plus 1. Now put I plus 1 within parentheses, within curly parentheses. Okay, yeah. I plus 1 space, get rid of the space after the 1. Yeah, okay. Times is the star, bin size minus 1 at the end. Okay, minus 1, because it doesn't go from 0 to 10, it goes from 0 to 9, right? So we need to go 1. All right. Okay, good. So now on the next line you can say cout. No, not count. Cout. Okay, now we're going to print the start of the bin, right? So and the bin is 5. Okay, so let's say we want to use a width. We'll do all the cosmetics later. Okay, after we finish the correctness, we'll do the cosmetics. Cout left shift. You want to say bin start. Yeah, and then left shift. And then space dash space, right? So we want to indicate the range there. Space dash space within quotes. Within quotes, you say space dash space. Within quotes, within double quotes, yeah, space dash space. Or you can say space to space TO, space TO. Right? No, don't say dash. You say TO, space TO, space. No, not yeah, space bar. There, yeah, that's what I meant. Yeah. Okay. All right. And to bin end. Underscore end. Right now, another left shift, and then you're going to left shift a colon within quotes, a colon and then a space, within quotes. Open double quote, and inside of that you say colon and then a space. No, colon is shift semicolon is a colon. That's next to L. Next to L, you see that? Next to the L key, you see the colon, 2 dots. That thing. Colon. That's called a colon. What happened? Something you need to see out, yeah? Okay. And then at the end, you say shift, and then colon. That is the key next to L. Key on the right of L. There you go. Right, and then a space after that. Space. No, space after the colon itself. Right. Now put a semicolon there. Do we need a semicolon? No, actually, we don't need a semicolon. Actually, so we'll shift more. Left shift there. Yeah, left shift, counts square bracket, counts square bracket, yeah, counts square bracket, and what is it got to be? I think it's I, right? And then at the end you say endl and enter, and semicolon, enter, semicolon, enter. Right here, click that blue arrow on the left nav. You see that blue stripe. On the left nav you see the blue stripe. Let's dismiss the blue stripe. Click that blue arrow there. Right next to you see the sign up and login button. Is sign up and login on the left? No, on the left. On the left, above the orange color button, you see the. No, more to the left. More to the left. More. Into the margin. Into the margin. In the margin. No, in how do I say this? Can someone help out
where
here?
like the website is. He means like the website itself, not the code. It's not in the
Not the code. Yeah, there you go. There. Exactly.
Yeah, right
Click
there.
Like that. Okay, good. That's better, I think. Yeah. Great. I think that is pretty much it. And then close the loop there. Curly brace. Now, if I'm not mistaken, hit enter so that return is separated out. If I'm not mistaken, that is a functional program that will run right now. Hopefully it won't have any errors, but it's, famous last words. So yeah.
Professor, can I ask you about the a little bit more about the algorithm they use to separate the bins? Because it doesn't really make sense to me.
Sure.
So Ashley, can you scroll up a bit? Sorry, if we reduce the test case, so for example, the num ends is around 100, right? So instead of 100 times 1,000, if the num ends are 100, the myran will randomly generate a number from 0 to 99.
Yes.
And then say the bin size is 100 divided by 50, which is 2, right?
Oh,
so,
wait a sec. Bin size is 100 divided by 2. No, by
100
50.
divided by 50 because the number of bins is 50.
Oh, so you only have 2 bins. Okay. Yeah.
Yeah. Oh yeah. No. The bin size is 2, but the number of bins is 50, right? Like this case.
Oh, I see.
Like
Okay. All right. Okay.
So it would
Okay.
it would mean that say if we make a random number of 0, it'd be 0 divided by 2, which cause it to go into the first bin or bin 0, right?
Yes.
But
yes.
we generate 2, we generate 1, then it will go to bin 0 as
Also
well.
Yes, also the first bin.
Oh, okay. But if we generate 2, then it will go to bin 1.
Yes.
So it will go every 2 number. It would go to certain bin.
Yes.
Oh, okay. Never mind.
Yeah.
I think I mistakenly counted my head. That makes sense.
Yeah. No, this
My
is
bad.
this is first time anyone does this. That is the classic place where they get stuck. Just figuring out the bins. Even as when we're coding it, even though I've done this many times, with other students, I still had to pause for a second and say, hey, bin number and so on. But not necessarily that everybody does that, obviously, but yeah.
Okay, thank you.
Obviously you can be better than me, right? So you shouldn't be. Good thing you asked, and you're solidifying this right away. Okay, good.
I have one other quick question before you. So if you scroll all the way down, Ashley, this is a question consonant to what Walter was talking about earlier. So I and bin size are both size T, right? I think that's the type. I think that's the term. But then we're saying bin start is an int. So why are we multiplying 2 size T's and giving that an int? Why aren't we using size T consistently throughout? So it would be line 29. You're saying int bin start is equal to the multiplication of 2 size T types. Why not just keep it size T?
It's a very good question, Thomas. Yeah. So Thomas's question is actually very good, right? And I think I shouldn't say very good in judgmentally, but I'm saying it's very instructive because it actually picked up a point that I should have probably made. We should ideally just use size T all over. just like Thomas just pointed out. Everything should be size T. The only reason we're using int is because it saves us a bit of typing here.
Okay.
And it's shorter. And then we know that, and also we know that the context in which we're going to use those numbers, the compiler is not going to complain.
Okay.
Yeah. So this is all of these things factor into it. But let's do it let's do it the way that Thomas recommended. Okay, that is better. So just change those two ints to size T.
Thank you.
Now, I think that should work. Unless Adam has already figured out a bug somewhere that I haven't looked at. Where's he gone? Yeah, he's not here. Last class, he picked up a bug that I didn't find. Oh, Adam's gone. What time is it? He usually goes 9:45. Okay. All right. Well, we got
I'm
5
here. I
minutes.
just had
We
my
can run it
phone
now.
off. Sorry.
Oh, you're here? I didn't even see your rectangle there. Okay, all right, so good. Anyway, if you run it now, I think you should see, you got an extra blank line, 8 and 9, right? You got an extra blank line after namespace, you can get rid of that. But you can run it now and it'll, there you go. Increase the size of the bottom part of the console. Increase the size of the console. There you go, right? So if you have 50 of those, we only have like, you should go, right? Now you see how, that in each bin, the number of numbers that fall into each bin is roughly the same. Yes? Because it's a uniform distribution. Now we'll do one more thing. And hopefully if you guys have time to stick around just a little bit, right? We'll be able to see this. Let's change that number in 2007, 1964, all those things, right? Those numbers into a sequence of stars. So that instead of seeing a number, you'll see a string of stars that is representative of the length of that number. Okay, right. So here's what we're going to do inside of that place where you do the cout. Inside of the where do you do the cout? Right. So here, after get rid of the endl, and instead of the endl, after that, yeah, get rid of it. Get rid of the endl. Right now, instead, just put a hyphen or something. Put a colon. Put a colon there. Put a colon. Right. Put a colon there. Yeah, colon within quotes, right? Shift colon quote within, put a colon and colon space. Yeah, right. On the next line, we're going to say, we'll put a comment on the next line. On the next line, put a comment. One more blank line there, and then put a comment. One more blank line, put a comment, right? And say, print out the counts as a line of stars. Print out the counts as a line of stars. Counts. Yeah, see that. Counts as a line of stars. As a line of stars. STARS. Yeah. So you can now, what you can do is on the next line, you're going to say stars. No. Oh, yeah. I see. Or use autocomplete again. Enter. Stars, plural, stars. Okay, on the next line, you're going to say size T num stars equals, So it's about the max is about, let's say it's about 2000 in each. So 2000, and then let's say we can print up to 50 stars. Okay, so what is 2000 divided by 50? That's 20 divided by 5 is 4. So 40 divided by 40 then. Okay, all right. So we're just going to divide counts of I by 40. Okay. Counts of I divided by 40. And unfortunately, we're using a number 40, right? A literal 40. Counts square bracket I. And then divided by 40. 40, right? And let's put a comment above this line. Right above this line, put a comment saying we're using the numeric literal 40 instead of a computed value, or we're using a numeric literal 40, and then within parentheses you can say that's bad practice. Okay, bad practice. We're only doing that in the interest of time, right? We're running out of time, and that's why. Oh, we're using. What did I say? We're using the numeric,
literal.
N-U-M-E-R, yeah, N-U-M-E-R-I-C, and numeric, I-C, yeah, numeric space, literal. And someone asked a question about numeric literals before, right? Literal 40 below, in the interest of time, but it is bad practice, right? So literal, L-I-T-E-R-A-L, L-I-T-E-R-A-L,
No.
space, yeah, space 40 below, but it is bad practice, right? No, below, in the interest of time, because we, yeah, in the interest of time, in the interests 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 of time, get rid of the it's a T after int, right? In the interest of time, right? Yeah, there. Backspace. Right. So on the next line, you say, but it is bad practice, avoid it. Right. And on the next line, you say, but it is bad practice, avoid it. Yeah, but it is bad practice, avoid it. Bad practice. Prac, P-R-A-C, T-I-C-E. Yeah. And then full stop, avoid it. Avoid it. A-V-O-I-D. 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 O-O-I-D. A-V-O-I-D. Avoid it. Okay, so now go on to the next line. After 40. No, yeah, that's fine. After 40, you hit enter. Now you're going to start a for loop for size t I equals 0. For size t I equals 0. I equals 0. I less than num stars. Yeah, semicolon, I plus plus. You need a space after the less than, space before the less than, right? So on the next line, you don't need braces there. You don't need, yeah, indent in 4 spaces. And you're simply going to say C out, left shift a star. That's all, right? C out, just left shift a star. C out, and then left shift, and then a star within quotes. Can be either single or double is fine. Yeah, put a star in there. Star. No, shift 8. The star, the times character. Yeah, semicolon at the end. Semicolon, right? Now, yeah. Now, next line. After the for loop is finished, backspace. Now, at the end of the for loop, backspace one more. Backspace. Go to the beginning. Line up with the F. No, under the F. One backspace. All right. Now you're going to say C out and L. C out and L. And L. Yeah, semicolon. All right. Now, if you run it, now you will see those numbers, but on the right side of the numbers, you'll also see these stars. All right. Now increase the size. No, increase the size of the thing. Yeah, right. So you see stars. Now you can see that every number is, all the numbers are equally represented. They are all falling into the bins on the right, approximately equally distributed. Let's change that. Okay. So now where you generate the random number, go back to your code. Right. Here's a really cool thing. Okay. And this is something that you should discuss. And in the forums, you should say, hey, we did that. And why is that happening? And then find out why it's happening and discuss it in the forums. Okay. Really, really cool stuff. Okay. Now, no, even above, where you generate the random numbers, where do you get the random number? Okay, here's what we're going to do, right? So my rand equals, where you have the rand here, so just go before the rand, okay? Yeah, open the parentheses before the rand. Open, no, before the rand, before the R, go before the R. Yeah, open parentheses there. Open parentheses, curly brace. No, open parentheses. Yeah. Now inside, get rid of the closing. The closing should be on the other side. So get rid of the closing alone. Just keep the open. Right now, where you have the rand call, have rand plus rand 3 times, right? Or 3 or 4 times, right? Copy that rand, copy that, drag now. Now you have to drag, click and drag, copy rand, open close within your clipboard. Not the whole thing, just rand, open close, right? Just rand, open close, copy it. Yeah, there you go. Copy that into your clipboard. Yeah, Command C will copy, by the way, okay? Actually, Command C is a shortcut for copy, and then Command V is for paste, okay? Now, not on the next line, on the same line after rand, on the same line after rand, on the same line, not there, after rand, after the call to rand, after the call to rand, get rid of that, yeah, inside.
Oh,
there you go. If there, exactly. Say plus, and then another call, plus, yeah, you need a plus before the rand, yeah, plus rand. Another one, paste, yeah, and plus another one too. You can do 4, 5, you know, I don't know. You can do as many as you want. Okay, let's stick with the 3 for now. Let's stick with 3. Right now, close the parentheses after the last rand, and then divide that by 3. Divide that by 3. No, the whole thing inside of parentheses. Now divide that by 3. There you go. Okay. Now on the previous line, let's put a comment. On the previous line. Put a comment saying, right? All right. So put a comment saying, now we can destroy the uniform distribution. We can destroy the uniform distribution by adding multiple randoms. ROY. No, or DEST ROY, destroy Rand's uniform distribution, right? Rand apostrophe S, Rand apostrophe S, apostrophe S. Apostrophe is shift double quote, right? No, just apostrophe is next to your return key. No, apostrophe is how do I say apostrophe? Someone should help me here. Rand apostrophe is next to your return key. The enter key and the key next to it is apostrophe. You got the return key, and the key to the left of it is called the apostrophe. No. You see the enter key on your keyboard? Enter key is on the right. Yes.
Oh, wait. On the Mac, yeah, it's not. It doesn't say enter though. On a Mac, it'll say return. So if you look at the key actually right next to the return key, it should be right to the left. There's 2 little dashes. Just click that one, it'll produce 1.
Return.
Yeah, so look at the return key on the right side of your keyboard. Okay, now do you see the return button? Just click the key right next to it. It should be right to the left.
No, not the return. The one next to it. The one near it.
Yeah.
This one?
There you go. That's the one. That's one. Right? You don't need 2, you only need 1. So get rid of one of those. Right? And then you don't need a space before that. So get rid of the space before that too. Right? And then put an S immediately after that. Okay. That is called a possessive in English, right? Possessive is apostrophe S. Okay, Rand's uniform distribution, UNIFORM, distribution, space distribution by summing multiple rands, by adding multiple rands. Now, if you run the program, you'll see a very interesting output. Okay, it won't be all the stars like that. It'll be different. But before you run it, increase the size of the console so you can see the output. Now run it. If you run it now, you'll see a different kind of output. Okay, now increase the size. No, something is wrong here. Something is wrong. We didn't do the rand properly. No, it's still equal. No, wait a sec. Go back to your, where are you creating the rand? No, yeah. Where are you creating the rand? That should have given us a Gaussian for sure. My rand. Did you? Wow, that is so strange. How come we're not getting
Professor,
yeah.
May I ask why are you using 3 rand in one line?
Yes, absolutely. Now, if you didn't use 3 rands, if you use only 1 rand, you're just going to get a uniform distribution. Yes or no? Uniform meaning every number is equally likely. Yes? Rand
I'm
gives a
not
uniform.
sure.
So rand, but by definition, yeah, of course, maybe you don't know because it's part of the documentation. And rand by definition, by design, right? Rand is designed to give you a number that is uniformly distributed, meaning if every number that rand gives you is equally likely to have happened. No number is more likely than another. That is what rand does. And it's very hard to produce that function. That is why we use a library function. Rand is give you a uniform distribution. Every number is equally likely. Yeah. Now we don't want to equally likely numbers because then all the numbers are boring. What we want is some numbers to be more likely than another. And we do that by adding multiple rands. When you add multiple rands, something incredibly beautiful called the central limit theorem kicks in. Okay, the central limit theorem will turn the sum of multiple randoms into a Gaussian distribution, a bell-shaped curve. Hey, actually, you are getting a bell-shaped curve, are you? No, you're not. So yeah, something is definitely funky here. Why are we not getting a rand plus rand plus rand divided by 3? No, that shouldn't matter. Why are we not getting a Gaussian distribution there? Can someone, there's someone, obviously, I mean, I'm going to experiment later and find out what the hell is going on here, but why are we not getting a Gaussian? Add a few more of the plus rands, and add 5 of those, not 3. Add 5, not 3. And then divide by 5 instead of 3. Yeah, run it now. But 3 should have also worked. Why didn't it work? Okay, so something is really funky here. This is not supposed to happen, by the way. Okay, we are supposed to get a bell-shaped curve because I've done this experiment hundreds of times in the past. When I was working, you only need to add 3 random numbers already, and it'll look like a bell-shaped curve. Only 3 random numbers, and you already get the central limit theorem will kick in, and it'll look bell-shaped. It's not uniform anymore. So why is it not uniform? Why is it not Gaussian here? My random is that. Okay, all right. We're out of time, but I'm going to leave that problem in your hands. Like math professors do this thing and say the hard bit is left as homework. Okay, but this is not the hard bit. Okay, this is actually the easy bit. And if you can't find the answer, I'll obviously find the answer and share. The question is, why is that summation not generating a normally distributed number or a non-uniform number that is supposed to give you a non-uniform number? Why is it not giving us a non-uniform number? Okay, because that means the central limit theorem is wrong. We know it is true, right? So why is the central limit theorem not working there? In statistics, the central limit theorem says no matter what the underlying distribution is, if you add multiple samples from the same distribution, you'll always get a Gaussian, a bell-shaped curve. Okay, so the numbers in the middle will be more represented than the numbers in the end. And you should get a bell-shaped curve, but you're not getting a bell-shaped curve here. So what the hell is going on? What time is it? I know, yeah, well, it's 10:03. So some of you have to go. But those of you who want to stick around to figure this out, welcome to stick around. But I'm not sure why.
I was just gonna ask, does it have anything to do with the data type? Like how many integer or like how long the integer can be if we're adding this many rands, or no? I mean, that might not be at all.
That is, yes, that is absolutely possible. Thank you for that. Change that int myrand into a long myrand, okay? Change that size t, make that int rand as size t, make that a size t. Now run it again after size t, now run it. No, so that didn't matter. That didn't matter.
Yeah, I'm not sure then.
Yeah, I'm not sure either. So I think we should leave this as homework unless, we can figure it out in class right here. This should definitely give you a Gaussian number. Let's see the random number generator. This is just, I don't think it's the matter, but let's see it just for good practice anyway. Go to the top of main and do an srand call. Just do an srand call. Yeah, after the declarations on line 14. Yeah, enter. and say srand, S-R-A-N-D, open parentheses, 2 open parentheses, open, no, open parentheses, parentheses. Parentheses. The other one, this one.
This one or this
No,
one?
No. The parentheses is the.
This one.
Shift 9. Yeah, there you go. Yeah, inside of that, say time, open parentheses again. One more. And in there, you say null pointer, NULLPTR, all lowercase, NULLPTR. And then at the end, put a semicolon and enter. Put a semicolon at the very end, enter, right? Yeah, run it one more time. Yeah, one more time again. Definitely I don't know what the hell is going on here. I need to look at the code, in a bigger window and things like that. And obviously you guys are welcome to encourage, especially to take a look and say, why the hell is it all the numbers are equally distributed? No, I should be able to see a bell-shaped curve there, right? The middle numbers there should be more middle numbers than the ends. So I don't know what the hell is going on. We'll find out, okay? I mean, we could leave it at this for now because we're at the end of time. And I would very much recommend that you get to the bottom, someone get to the bottom of this, okay? Why are we not getting non-uniform numbers here? We're still getting uniform numbers even after adding multiple rands. And that is not supposed to be the case, according to theoretical statistics anyway, right? Well, not theoretical. Actually, central limit theorem is not theoretical, right? I don't know if there's a theoretical proof. Or maybe there's a theoretical proof. But certainly empirically, that is when it was observed first, right? Empirically, people notice that, things that are any distribution, when you add them all together, you still get a bell-shaped curve. Everything is normal, right? Everything settles to a normal distribution. So that is not happening here. Why is it not happening? And that's very interesting.
Can we scroll down a little bit so we can see the code a bit more?
Yeah, could you scroll down a bit? Yeah. More, I think, even more. That is really strange.
What's the seed that we're using for the random engine?
No, it is just our standard random. We're using time.
Oh, it's just standard.
Yeah.
Okay.
Time and anyway, I find this really puzzling. Okay, this is just a simple, small program. 50 lines of code, and I'm finding this really puzzling. I don't understand why the sum of these rands is not giving us a non-uniform rand. Okay, so something for you to noodle on and find out. I will probably find out, but I won't share my findings, which means that you guys will have an opportunity to share your findings. Okay, this should definitely give us a non-uniform random, and it's not. So please do a little bit of looking into this investigation. Thank you, Ashley. Okay, you're absolutely brilliant today in helping out and coding. Very nice, very nice. Okay, and look at the program also, right? Program is very nice, looks nice, and it's all in good sections. And you can look at the program and understand it, and it's all very. And in fact, everybody can look at this program to understand the concepts about arrays, loops, branching statements. All of that is in this program before the midterm. You can look at it and say, hey, what's going on, right? This is what I'm doing here. This is what I'm doing here. So all of this will actually be very, very solid in your knowledge. So thank you, Ashley, all right, for your patience also, right? Very patient and doing these things, right? Anybody else have any questions? Otherwise, we will call it a day. Best of luck for your Thursday midterm. No class on Thursday, okay? Unless you guys want a class, okay? If anybody wants a class on Thursday morning, because you don't have to take the midterm in the morning, okay? You can take the midterm in the afternoons too. If anybody wants a class on Thursday morning, a bunch of people, email me, okay? Email me saying, hey, Prof, can we have a class on Thursday morning? We'll have a class, and then you do the midterm in the afternoon. That's fine, okay? I don't want to impose on Walter to also come on Thursday, but it's optional. Walter, if you're free, please, and if you're free and there's a class, please feel welcome to come to class and help out as usual. But otherwise, I wish you the absolute best of luck for your midterm. Enjoy, and the rest of the week. And I'll see you. And I hope to see the answer to this puzzling problem, right? That we encountered today. Was this a useful class? Did guys? Yeah. All right. Great. Thank you all. And I'll see you later. Okay. Bye.
Professor.
Thank you. Bye.
Yeah. Mark.
May I ask you something?
Sure.
So I feel like there are not enough questions on Reddit for me to answer, or at least like that haven't been answered yet.
Oh, you don't have to answer people's questions, right? You can also make observations about quests, or you can make, Ashley's been making these posts about some concept. Hey, this is a concept, and here's what it means. You can do that too, and then, or you can say, well, in the process of trying to understand this concept or trying to explain this concept to other people, I came up with a question myself. Can someone answer that?
Oh yeah, like I have a question about, like, I know it will be more apparent when we will start using classes, but the asterisk. So when you have the end operator, the one now shift 7, how do you call it?
Shift 7, ampersand. Yeah, shift 7 is ampersand.
So
you have a question about
when you do that, you pass the address, like the actual, like
yes.
you pass a reference, right? Instead of passing like the immediate, right? I think that's because I'm taking CS10, and I think that's how we call it in assembly, right? You load an immediate, which is just a number. It's not like a place in memory, right? So if int equals 4,
yes.
and you load
in assembler, that's what it's called, an immediate value. You put a number in the register.
Right.
Yeah.
Okay. Right, but when we have an asterisk, what does that mean? Because I think that's different, right? I think it's a pointer to the address.
No. So the asterisk is the exact opposite of ampersand. They're like log and e to the x. Log and e to the x are opposite, right? In math?
Yeah.
So asterisk is the exact opposite. So meaning, if ampersand gives you the address of a variable, asterisk will take the address and give you what's inside the address. Will give you the variable itself.
Oh, so it's like load word if we talk in assembly.
It is a load word at that location.
Okay, that makes sense. Okay, I see. Yeah,
so
thank you.
So it's called the dereference operator, because the ampersand is the reference operator. The ampersand is a reference operator, isn't it?
That's kind of weird that the. Oh, sorry. Go ahead.
Yeah, the star is called the dereference operator. Ampersand is reference. The star is dereference, the opposite of reference.
Dereference?
DE or dereference, right? So you say getting on a plane is deplaning is getting off a plane. Detraining is getting off, right? So DE and then reference. That is the opposite of reference.
Right. That
unreference.
I want to say. Right. It's kind of weird that the default, like if you don't put anything in front of the variable, it's just the immediate value. Why is that default? Is there a particular reason? Is that
because that's the most common case. The most common case when you're using a variable is just to use the value of the variable. Yes. Just like that.
Does it have anything to do that, like, if somebody gives you like functions, right, and you don't want him to like change anything, like any stored values, so there wouldn't be memory override, you would give the immediate value and not just like the address to a memory location that you don't want him to change, right?
No, that's not that is not the good way to do it, right? You can pass a constant, like you're saying, right? If you want that person not to change the value, you can do a whole bunch of different things. Okay,
right, you don't pass the address, right? You don't pass the address, you pass the copy.
Yeah. Also, you don't have to pass the address in order to get to the value. You can actually say, I'm going to pass this parameter by reference, right? Meaning that in the signature you have the ampersand, it'll get passed by reference, meaning that even though you don't have the reference in the call function, it will still go through the address and get the actual value. So that's one way to do it. But if you don't want a called function to access and change your values, you put the word const in front of it. Then the compiler will have it back and say, well, even
Wait,
though you're
I'm
passing
sorry. Can you say your last? I kind of lost you there.
So when you pass a reference
Mhm.
to a function, saying
Right.
here's the address, right? But you don't want that function to change what's in this address. Then you put the word
Right.
const in front of it. If you put the word const in front of it, you'll still pass the address, but that guy won't be able to enter the address and change inside of it. It can read it, but it can't change it.
Oh, so it's like kind of giving the immediate value.
It is
the
like
co-
being
the
given the
constant.
immediate value. Yeah, I don't want to make that one-to-one comparison. It's not exactly immediate
Right.
versus right.
Right.
Immediate is slightly different. You know, it does.
Yeah, I
something
mean
different.
immediate that it's not something stored in memory. It's like loading, a value. You know what I mean?
Yes, you don't have to dereference that. Yeah, that I get what you mean. It's immediate meaning it's right
Mhm.
here. It's not, you don't have to go to a memory location to get it. So it's
Yeah.
immediate right
Yeah,
now. Yeah.
I see. I think I can do a post about that, about like the differences and explain like about, getting the address, getting the value, or getting a copy of that value.
Yeah. And I think it'll be hugely useful for just before the midterm, because that is a topic in the midterm. It'll be very useful.
I see. Okay. Thank you.
Yeah. Thank you, Mark, for all these great questions you're bringing up in class too.
Of course. Thank
All
you.
right. See you guys later. Thanks, Walter.
See you.
Take care.
Bye. Hey, Walter, take a look.